dynamics is a branch of physics concerned with the study of forces and torques and their effect on motion, as opposed to kinematics, which studies the motion of objects without reference to its causes. Isaac Newton defined the fundamental physical laws which govern dynamics in physics, especially his second law of motion. Principles. Generally speaking, researchers involved in dynamics study how a physical system might develop or alter over time and study the causes of those changes. In addition, Newton established the fundamental physical laws which govern dynamics in physics. By studying his system of mechanics, dynamics can be understood. In particular, dynamics is mostly related to Newton's second law of motion. However, all three laws of motion are taken into matter because these are interrelated in any given observation or experiment. Linear and rotational dynamics. The study of dynamics falls under two categories, linear and rotational. Linear dynamics pertains to objects moving in a line and involves such quantities as force, mass inertia, displacement, velocity, acceleration and momentum. Rotational dynamics pertains to objects that are rotating or moving in a curved path and involves such quantities as torque, moment of inertia, rotational inertia, angular displacement, angular velocity, angular acceleration and angular momentum. Very often, objects exhibit linear and rotational motion. For classical electromagnetism, it is Maxwell's equations that describe the dynamics. And the dynamics of classical systems involving both mechanics and electromagnetism are described by the combination of Newton's laws, Maxwell's equations, and the Lorentz force. Force. From Newton, force can be defined as an exertion or pressure which can cause an object to accelerate. The concept of force is used to describe an influence which causes a free body to accelerate. It can be a push or a pull, which causes an object to change direction, have new velocity, or to deform temporarily or permanently. Generally speaking, force causes an object's state of motion to change. Newton's laws. Newton described force as the ability to cause a mass to accelerate. His three laws can be summarized as follows. First law, if there is no net force in an object, then its velocity is constant. The object is either at rest, or it moves with constant speed in a single direction. Second law, the rate of change of linear momentum p of an object is equal to the net force Fnet, that is, dp dt equals Fnet. Third law, when a first body exerts a force F1 on a second body, the second body simultaneously exerts a force F2 equals the F1 on the first body. This means that F1 and F2 are equal in magnitude and opposite in direction. Newton's laws of motion are valid only in an inertial frame of reference. See also, multibody dynamics, rigid body dynamics, analytical dynamics, references. Further reading, Segatum. Calculating engineering dynamics using Newton's laws. Bright Hub. Retrieved April 10, 2010. Wilson, C. Kinematics and Dynamics of Machinery. Pearson Education. ISBN A978-0-201-35099-9, Sick, H. Hoswayag, F. Dynamics of Machinery. Theory and Applications. Springer Science Plus Business Media, Dordrecht, London, New York. ISBN A978-3-540-89939-6A.